Okay, now we are ready to actually run our TCP congestion control experiment. Before doing this, let's go again the steps that we have done so far. So we have the server and the client up and running in the virtual wall. We have installed in both the server and client node the iPerf tool to create the TCP connection between them. We have already launched in the kernel space the TCP probe. We have inserted in the kernel the TCP probe module, and by using this command, we have instructed the operating system, the Ubuntu from right here in the client node, to copy every information that it gets from the TCP probe module into this file, so that we can collect all the information that we need. As you can see here, here is the file. Anyway, so what I'm going to do here is we are going to again start the iPerf server on the server side, and we are going to execute the iPerf client command on the client side. But right now what we're going to do is we are going to execute this command for a bit longer so that we can collect as much information as possible and create a more proper graphical representation of these results. So we have here the minus I 1 second, minus T, we will let it run for about 300 seconds, and minus C, here is the host that I want to connect to and send information. So for 300 seconds, we have created a connection from this client to this server, and currently we are sending at the rate of 95 megabps. Note here that this rate here is about 95, 96. When the if you can see here at the modified traffic shade, the bandwidth currently between those two nodes is 100 megabps. This means that everything is working smoothly. What we are going to do in a while, let's say at about 100 seconds, is that we are going to go to the virtual wall website and then at this traffic control tool, and we are going to add some delay in the link between the client and the server, and see how this delay will affect our little experiment. So let's let it run smoothly for about 100 seconds. Then we will add the delay for 100 seconds more, and then we will remove it again and see how the TCP will respond to this. So okay, it's about 100. We will put 5 millisecond delay here, then we put execute, and now we can see that the connection between the client and the server is almost immediately affected. From 11 megabytes here, as you can see, we have dropped to about 7 or 8 megabytes transmission. Let's view here also the server. So we will leave this to run for about 100 seconds more, and then we will remove this delay and see how and see if the connection returns back to its previous state. Okay, I guess now we can go here and insert 0, press execute, and we will see that the TCP connection is immediately has returned to its previous state. It sends again about 11 megabytes, and this is per second, as you can see. This report is every second, as you can see, and we have about 95 megabits per second in the link. Okay, so the TCP connection is ended. As you can see here, we have a small report both in the client and the server side. Here is how many gigabytes were transferred. This is the rate. As you can see, the information is the same in both sides. So what we need to see here is if we collected any information during this process. So as you can see here, we have the TCP out file, and if we actually look for check its size, it will see that this file is no longer 0. It actually contains a lot of information. If we do this, I'm not sure if this works. Yes, as you can see here, this is a 39 megabyte file, and this is a text file. If you can see, if I actually try to open it, in here we have information about the TCP connection between this node from this port to this node and this port. Okay, so I'm not going to discuss right now what all these values are. What I'm going to do is we will stop this video right here, and I will and in the next part we will discuss how we can take this video, download it locally, and then create a graphical interface and actually see the parameters that we need for this specific experiment.